Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. How's everybody doing today? Hopefully everyone's staying safe, with the wildfires going on. So that's the first thing I want to say today, so that, I know a lot of communities around, Fullerton and kind of a lot of the surrounding areas are, they're evacuating because the fires are getting close. So at any time during this lecture, if you guys get the call to evacuate, just, don't finish the lecture, just, put everything down, and I want you guys to get to safety, okay? Because your safety is, always gonna be the most important thing. For this class, the lectures are recorded, so, there's no reason to kind of stick around. The grind don't stop though. Yeah, that's true. So I mean, for this lecture, you can definitely view it remotely. So take your safety is the important thing. So during my lecture last night for my grad students, I had a couple of them that had to evacuate mid-lecture. So definitely take all the precautions you need to. I was discussing earlier too that I'm kind of in an area where it's getting a little bit close to the fire, so I might have to evacuate kind of midway through the lecture too. So if that's the case, then whatever we don't finish, I'm going to record the rest of it as a video and then post it on YouTube. But hopefully I'll be able to stay until at least the end of the lecture. Okay. So today we're starting our last week on economics. So this is the last week we'll be seeing this, and then starting next week we'll be looking at ethics. Our midterm is also next week. So those are the two things for next week. And so our last topic for economics is going to be inflation. And so this is kind of a, I think it's a nice topic to kind of end on, just because it kind of addresses a lot of the kind of assumptions that we've been making up until this point. And I think it's something that's just generally just really interesting to look at. Okay. So besides that, I did mention the midterm. So our midterm is going to be next Thursday. It's going to have this. It's going to be the same format as the last exam. So I'm going to basically open up the exam at 1 p.m. next Thursday, and then you guys are going to have 24 hours, so until 1 p.m. on Friday to finish the exam. So it's going to be, it's going to take place on Canvas as well. So you can access the exam the same way. Everything's going to be the same. The only thing, the thing is that the content is going to be different. And so the thing with the second midterm is that it's not going to be cumulative. And so all the stuff that we covered kind of at the beginning of class, I'm not going to test you explicitly on that. Although as you've been seeing, you're still going to need to know, how to do how to use the compound interest tables, how to take present words, because all of those are part of, like rate of return analysis, benefit cost, taxes, and all that stuff. Okay. And so the first topic that, that's going to be covered on the second midterm is going to be rate of return, and then it's going to be cover everything up until this week, so on inflation. Okay. All right, so the question is, what was the average time for everyone to take the exam? Roughly 3 hours. Okay, yeah, it's I'll admit that I didn't explicitly time myself taking the last exam. I wrote the same amount of questions as I usually did, for like an in-class exam, but I didn't time myself performing the actual exam itself. So I'll try to be a little more careful this time and actually time myself to make sure that it doesn't take nearly as long. But yeah, I when I wrote my solutions, I kind of did it pretty leisurely, kind of with ice cream in one hand and writing the solutions in the other one. So so I didn't really take much into account the time. So I'll be a bit more careful about that this time. Okay. So are there any questions on that? I know there's a homework out there right now too. So are there any questions on the homework or the exam or just anything that we covered before we begin today?
Wait, the homework is due next week, right?
Homework is due next week. Yeah, homework is due next Tuesday, I believe. And so, since the homework's going to be due right before the exam, I'm going to do the same thing as last time. So as soon as the homework is due, I'm going to post the exam, the solutions for the homework. So you'll have those to study for the exam as well. Yeah. I'm also going to do a remote review session too. So I'm going to record a video. I'll probably do it over the weekend. Because we're covering new content up until Thursday, so I want to give people at least a day to at least stew with the new content to decide what are the things that you want me to cover in the review. And so I'll probably put up a poll sometime on Friday where you can vote on the topics that you want to see in the review session, and I'll record it over the weekend and post it so you guys will have that to study as well. Okay. All right. Any more questions? Okay, so let's go ahead and get started. Okay, so our final economics topic for this portion of the class is going to be inflation. Okay. So I think, I'm not sure what it was for you guys, but growing up, I heard the term inflation all the time. But I didn't. It wasn't until I actually taught this class that I really understood what it was. Right? And so inflation, so up to this point, we've mostly just been worried about cash, right? And so we would do things like present worth analysis, annual cash flow, and everything's about cash, right? And so inflation actually doesn't really have anything to do directly with cash, right? And so what inflation actually is, inflation describes generally how not the cash itself, but it quantifies how much purchasing power a certain amount of cash has. Okay, and so what does that mean, right? Because while money, I think is kind of been glorified in a lot of different things. So unless you're taking your money and taking a bath in it, what you do with your money is you usually exchange it for goods, right? So you use it to buy food, use it to buy supplies, use it to buy entertainment, stuff like that. And so what inflation actually tracks is not the cash per se, but inflation tracks prices. Okay. And so I still remember, when I was in high school, there was this place I would used to go with my friends all the time. It was $5 for a bagel sandwich, a bag of chips, and a soda. So at the time, that was great. But it seems, nowadays it's really hard to find unless you're going to like Burger King or Jack in the Box. But nothing wrong with that. I love myself a good Burger King. But prices for food and everything is going up and up and up. Yeah. And yeah, tuition, of course. Yeah, tuition's always going up. And that's the unfortunate thing. And so, the reason it's called inflation. So inflation is actually, just one way. So inflation basically describes how prices increase. Okay. And so this is kind of true in general. Okay. And so an increase in price over time is called inflation. And so the opposite can be true too. And that's called deflation. Which means that prices go down over time. And that might happen on kind of a micro scale, like, actually kind of, what's going on right now with the pandemic, you might see some things drop in price just because it's harder to sell things. But generally, we see prices increase over time. Okay. And yeah, gas, yep. Costco food, yep. All the prices are going up. Yeah. Okay. And so what does this mean for us, right? And so because of inflation, what that means is that, if you have, money that you have today, if you wait to spend it for the future, that money is going to be less valuable. Okay. And so what you say is that future dollars are less valuable than present dollars. Okay. And the reason is because in the future, because of inflation, you'll be able to buy less with your money. Okay. And so we've already kind of seen that, we already know that future dollars are less valuable because of interest rates, right? And so, any money that you have today, if you don't invest it, then in the future it's going to be less valuable because you could have invested that money and gotten some more money later because of interest rates, right? And so inflation kind of adds another layer on top of that, where like if you wait to spend your money, in the future it's going to be less valuable just because the prices of things are just going to be expected to increase over time. Okay. Right. So how does this affect our calculations? So because a lot of the calculations we've been doing, they usually track the lifetime of a project over several years. The fact that we're not taking inflation into account is kind of a big deal, right? And so I'll give you kind of just one basic example, right? And I think at the time, when we talked about this, a lot of people pointed out that that this is a big assumption because of inflation, right? And so if you remember when we were doing like our present worth analysis, in order to do our analysis for project with different timeframes, we had to buy replacements whenever our machine broke down. Okay? And what we assumed at the time was that the cost of future replacements were going to be the same as our original cost. And so because of inflation, we know that if we buy the machine today, if we have to buy the replacement 6 or 7 years in the future, then the replacement is going to cost more just because of inflation. If it's over 6 or 7 years, then a lot of things could change. Okay. And so what we're going to do this week is we're going to do, just kind of like a lot of things we're doing in this class. We're only kind of basically scratch the surface for inflation, but I just want to kind of introduce the general idea, do some basic calculations and, introduce kind of the terminology to you guys, just so, you can kind of take this information and kind of build on it, if you get into like a management role or, project, any kind of big projects. Okay. Okay. Any questions on this so far? Okay. Okay, so let's talk about some of the causes for inflation. Okay. So there can be a lot of causes, but we're going to boil it down to kind of the 4 main ones. Okay. Right. So the first cause that we're going to talk about is the money supply. Okay. Right. And so money supply just refers to just how much money there is in circulation. Okay. Okay. And so there's a government agency that's responsible for this, and they're called the Federal Reserve. Okay. And so generally, what you can expect is that if there's a lot of money in circulation, so the Federal Reserve kind of prints a lot of money, then there's kind of more money out there. And then if there's more money, then purchasing power tends to decrease. Okay. Okay. Yeah. So someone made a comment. Yeah. Theoretically, if you can somehow acquire a large amount of cash and burn it, would the value of money go up by reverse inflation. Yes, theoretically, yes. And Carter is right. So the Fed also, they take that into account to try to maintain the balance. There's also, just people just lose money all the time too. So I mean, there's money can also exit the system, but the Feds also kind of print more money to kind of keep everything in balance. Yeah. Okay. All right. So the next thing is international exchange rates. Okay. And so prices of things can be adjusted based on the strength of the dollar relative to other currencies. Okay. Okay. This is especially true. That's especially true in kind of the global economy that we're in today, where a lot of things are shipped overseas, they're made overseas, they ship here, and and vice versa. So depending on how strong the dollar is internationally, then that can affect prices here at home. Okay. Okay, and so the next thing is called cost push inflation. Okay. And so this can happen when when the companies that produce goods, they kind of push some of their costs onto the consumers. Okay. Okay. And so this typically happens, sometimes there might be new laws or new regulations that take place where companies have to, pay more money to produce goods to, to have increased safety regulations or to pay more staff. And in order to keep their margins the same, they sometimes push these costs onto the consumer. So that's one way. Okay. Okay. Yeah. So Kang made a great comment too. So that's also true. Okay. And so the last cause for inflation, which I think everyone kind of understands as supply and demand, is called demand pull inflation. So I'll write that on the next page. So before I go there, are there any questions on this? Okay. Okay. And so in demand pull inflation, if the demand for a good increases, then this will increase the price of the good. So this is basically supply and demand. Okay. Okay, so those are kind of the four main causes for inflation, but there's a lot of other things that can happen as well that can affect prices because it's a very complicated system, but these are kind of the four at least simplest ones to explain. Okay. Okay, and so let's go for some definitions that will help us with our calculations now. Okay. Okay, so let's go over kind of our three rates. Okay. And so the first rate that we'll go over is simply just the inflation rate. Right. And so the inflation rate is basically just a percentage, and this just simply describes how much prices will increase per year. And so if we have an inflation rate of 5%, then we can expect, you know, prices to increase, you know, by 5% next year, right? And so your $1 Taco Tuesday will be $1.05 next year with a 5% inflation rate. Okay. All right. So the next definition will be real interest rate. I bring Taco Tuesday up because it's that's kind of what I experienced for inflation when I was in high school. I remember when I was in freshman, you know, tacos at California Fish Grill were $1 on Tuesday, and I've just seen that just go up and up and up every single year. So it's no longer that great of a deal anymore. Okay, and so the next one we'll go over is called the real interest rate, and so we'll give this the symbol I apostrophe. Okay, and so what this measures is the real value of money excluding the effects of inflation. Okay? Okay. And so sometimes this real interest rate is often called the inflation-free interest rate. Okay. Right. And so actually, you know, for all the problems that we've been doing before, we've actually been using the real interest rate for our calculations. We assumed that, you know, inflation, when you assume that, you know, inflation is not going to take into account, you implicitly kind of use the real interest rate. Okay. And the last one that we'll go over is called the market interest rate. Okay. And so this will just simply be I. Right. And so this market interest rate this is the rate that one obtains from the general marketplace. Okay. And so if you take out a loan from the bank or you are investing some money, this is the interest rate that's given to you. Okay. And so this market interest rate, you can kind of think of it as it combines the effects of both inflation and real interest rate. Okay. Another way to think of the market interest rate is this is the rate that you're going to obtain on your actual cash. Okay? And so if you actually you invest like $1,000 into a bank and they give you a certain interest rate, then you know, the market rate is you know, basically going to describe how your cash is going to grow. Okay. Okay. So we're gonna do some examples on these in a bit, but are there any questions on these so far? Okay. All right, so so there's actually a mathematical relationship in between these guys, okay? And so the relationship is given by the following. And so on the left-hand side here, we have I, and so I by itself, this is just the market rate. And so I is gonna be equal to I prime, which is our real interest rate, plus F, which is our inflation rate, and then I prime F, okay? And so you can use this formula to basically, you know, compute either one. If you know two, you can compute the last one. Okay. Okay. And so, you know, just like I mentioned previously, we've kind of been mostly just using the real interest rate because we've mostly been ignoring the effects of inflation. But going forward, especially for a problem that takes inflation into account, you're going to have to kind of identify which of the different rates are given. Okay, and so oftentimes a problem will say it'll give you like a rate of 3%, 4%, 5%, and so the first thing that you always have to do is you have to say, okay, I'm giving a rate right here. I'm giving a percentage. What kind of rate is this? Is this the inflation rate? Is this the real interest rate, or is this the market rate? Okay, and oftentimes it's not often kind of clear. And so I want to give you guys some kind of general rules that you can use to identify how to classify a rate that's given to you in a problem. Okay. All right. And so the first thing is that if a rate is given that's associated with some kind of savings account or a loan, okay, okay. In these situations, this is usually the market rate. Okay. Right. And so the second case is that if we have like an engineering project, where the costs and benefits are estimated at at a certain a certain rate, and so this is kind of like accounting for engineering projects. So this is kind of what we've been doing for most of our problems. Okay. And so in these cases, this is usually going to be the real rate. Okay. And so, for all the problems that are going to be given, from here on out, you have to be able to determine, which interest rate or what kind of interest rate is going to be given to you in the problem. Okay. All right. Any questions on this before we jump into an example? Okay. Okay. And so for this example, let's say that we have a professional golfer. Okay. And she won, let's just say that she won a tournament recently and she wants to invest some of her earnings. Okay. 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 And so the bank will pay her 5.5% interest on this account. Okay. Okay. And the inflation rate is given to us in this problem. Our inflation rate is going to be 2%. Okay. Okay. And so let's say that the amount of money that she's going to invest is going to be $1,000. Right? Okay. And so the first part of the problem is going to be, is to take these two interest rates or these two rates here and then classify them. And then from these two, compute the other one. So the first one is going to be identify I, F, and I prime. Okay. Okay. And so the first one we'll do, let's do F first. Okay. So F, remember, is our inflation rate. And so this is given to us directly in the problem. So we know that we have an inflation rate of 2%. Okay. Sounds pretty easy. Okay. And so the next thing that we have here is the 5%, 5.5% that the bank is going to pay annually on this account. Okay. And so would you classify this as a market rate or a real rate? Okay. That is the question. Okay. All right. And so for this problem, since this 5% is given by a bank, right? And what this 5.5% represents is a growth in actual cash. Okay. Okay. And so basically what that means is that, the actual $1,000 that, that this golfer can touch and deposit into the bank, that's going to grow by 5.5% by the next year. Okay. And so since this is given by a savings account that's on a bank, this is a market rate. Okay. Right. Because this is a 5.5% that's offered by the market. Okay. And so another way that you can tell is that this 5.5% doesn't take into account, how expensive things are going to be in a year. All this 5.5% describes is how much this money is going to grow within a year. Okay. Okay. And so now that we've identified this 5.5% as the market, and we know this 2% is the inflation rate, we can compute the real interest rate. Okay. Okay. And so let's use our formula from before. So we have that I is equal to I prime plus F plus I prime F. Okay. And let's solve this for the real rate, which is I prime. Okay. And so if we do that, we end up with I prime is equal to I minus F all over I plus F, or 1 plus F, sorry. Okay. And so if we plug in the numbers for this, then we get 3.4%. Okay. And so remember what the real interest rate represents. The real interest rate basically represents the interest-free rate, or the rate at which her money is going to increase, without taking inflation into account. Okay? Or I should say that it's the real interest rate basically describes how much her purchasing power is going to increase within a year. Okay. And so I think maybe the definition was a little bit backwards before. I think I might have misspoke. Where the market rate, that's how much your actual money is going to increase, but the real rate will describe basically how much more purchasing power that she's going to have. Okay. And so what this first part of the problem states is that, if she puts this $1,000 into the bank, that $1,000 itself will grow by 5.5%. But since prices are going to increase by 2% in a year, then that $1,000 will only be able to purchase 3.4% more stuff by the next year. Okay. And I'm going to illustrate that point with kind of the next part of this example. Okay. But before I do that, are there any questions on this? Okay. Okay. And so in part B of the problem, let's say that this professional golfer, she's putting that $1,000 away so that she can buy golf balls in the future. Okay. And so let's say that golf balls today cost $5. Okay, not 5,000, cost $5. Okay. And so let's compute how many golf balls that she can buy today, and then how much golf balls that she can buy in a year. Okay. Okay, and so let's do today first, okay? All right. And so today, what she has is $1,000, right? And then, you know, if golf balls cost $5 each, okay, we can just simply divide 1,000 by 5, and then we get 200 golf balls. Okay. And so now let's compute, you know, how much, let's first compute how much golf balls the price is going to increase in a year, and then let's compare that to how much money that she's going to have in her bank account, okay? Okay, so this is in 1 year. All right, so in 1 year, you know, the price of golf balls are going to go up by 2% because that's our inflation rate. Okay? Okay. And so to compute this, we can just simply say that, you know, new price is equal to 5. Okay. So even though this is the inflation rates, we can still use, you know, it still follows the same rules for compound interest, right? And so we can say that the new price is equal to 5 times F over P with 2% and 1 year, okay? And so in other words, it's going to be 5 times 1 plus 0.02, okay, raised to the 1 power. And this is going to be 510, okay? And so in 1 year, the price of golf balls will go up by 10 cents, okay? And so that's the new price of golf balls. Right? But, you know, during that 1 year, even though golf ball prices are increasing, you know, that the amount of money that this golfer has will also be increasing, right? Because she put this, she put her $1,000 in the bank, and the bank is going to grow that $1,000 by 5.5%. Okay. Okay. And so the money in the account is going to be 1,000 times F over P, 5.5%. Okay. And 1. All right. And so, you know, 5.5%, we don't have a table value for that, but, you know, just intuitively, we know that, you know, we're going to increase this by 5.5%. And so this is going to be 1,055. Okay. And so in her bank account, she's going to have $1,055. Right. And so now that we have the amount of, we know the amount of money that she has, and we also know the price of golf balls, we can just perform the same calculation. Okay. And so the number of golf balls she can buy in a year are going to be 1,055, which is the amount of money she has in her account, divided by $5.10, which is the price of golf balls. Okay. And then, you know, if we perform this calculation, then she can buy 207 golf balls. Okay. Okay. Any questions on this part right here? Okay. All right. So now let's take this amount and let's compare that to the amount of golf balls that she could buy, you know, today. Okay. And so let's take the ratio actually. So let's say 207 golf balls in the future. Okay. And let's divide that by 200 golf balls today. Okay. And then what we should get is 1.035. Okay. And so what this tells us is that, you know, accounting for, you know, after we account for inflation and, you know, our money and her money has grown, she can buy 3.5% more golf balls in a year. Or another way to say this is that her purchasing power for golf balls has gone up by 3.5%. Okay. Okay. And so let's compare this actually to the real interest rate that we computed from part A. Okay. Okay. And so in part A, we computed the real interest rate to be 3.4%. Okay. And so it's no coincidence that these guys are, you know, I know that they're not exactly the same, but they're very close, and that's no coincidence, right? And so that kind of gives you another interpretation for the real interest rate, and it's actually the one that I usually think about it, and it's a little bit easier to remember. Is that the real interest rate is that, you know, accounting for the fact that, you know, your money's going to grow in a bank account and account for the fact that prices are going to increase. This real interest rate basically tells you how much your purchasing power is going to increase over time. And so the market rate is going to tell you how much your cash is going to grow in a bank account, but then remember, that's different than how much purchasing power that cash is going to have. Okay? And so the real interest rate will tell you, you know, if your cash is growing at a certain rate and the inflation is growing at a certain rate, you know, how much more purchasing power or less purchasing power will you have, you know, in the future. Okay. All right. Any questions on that? Okay. All right, so there's a part C on this problem. Okay, just for you know, just to kind of show you kind of the other way. Okay, and so part C says let's repeat the problem, but now let's say our inflation rate is 8%. Okay. 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 And so if our inflation rate is 8%, then our inflation rate is going to be higher than our market rate. Okay. And so let's compute. Right, so let's compute our real interest rate. Okay. And so just like before, our real interest rate, I prime, is going to be equal to I minus F all over 1 plus F. Okay. And it's going to be a minus 2.3%. Okay. And so what this tells us is that if the inflation rate is 8%, or the price of golf balls are going to increase by that much, then we're going to have 2.3% less purchasing power in the future. Okay. Okay. And so we can basically use this information to compute how many golf balls that we can buy in a year, you know, if the inflation rate is 8%. Right? Any questions on this? Okay. And so if we apply this to our golf balls, because remember, if we buy the golf balls today, we could buy 200 golf balls, right? And so if we multiply this by our real interest rate, okay? And so instead of a 1 plus, you know, 2.3%, we're going to do 1 minus 0.023. Okay. And so this is going to be equal to 195 golf balls. Right. And so if the inflation rate is 8%, and so the rate at which price is increasing is outstripping or outpacing, you know, how much our actual money is growing, then, you know, we're going to have 2.3% less purchasing power. That means we can buy 5 less golf balls. Okay. Any questions on this example?
On part A, didn't we lose shouldn't the percentage be negative too? Since we invested 5.5% in a bank,
Mm-hmm.
and we got around 1,055,
Yep.
and if each golf ball was $5, shouldn't we be able to buy about like 11 golf balls? But since inflation happened, we were able to purchase 4 less. Shouldn't the
Yes.
percentage be negative?
Right. Oh, and so you're talking about the case of if the inflation rate was 0, and then we'd be able to buy 211 golf balls, right?
Yeah.
But you know, there's kind of these two processes happening at the same time. So, you know, at the same time that our $1,000 is growing by 5.5%, then the price for golf balls are also climbing by 2.2%. And so you can't and so, you know, because, you know, that we don't get that 1,055 until a year later, we can't compare that to the price of golf balls today. And so we have to compare that to the price of golf balls at the same time that we take the money out of the account. And so we can only compare that 1,055 to the after the price of golf balls have increased by 10%, or by 2%, sorry. And so, you know, if you have money that grows over time, you can't compare things to the price of that today.
Okay.
That kind of makes sense. So it's, you know, if your money is going to grow, then the prices also have to grow at the same time. So you have to compare things at kind of the same time like that. Yeah.
Okay. So it's still positive because they're both growing at the same time.
Exactly. Right. Yeah.
Okay.
And so, yeah, for part B, you know, our money is growing faster than, you know, the price of golf balls are growing. So that's why we can buy 7 more golf balls in that case. But in part C, the price of golf balls is growing faster than our money, and so that's why we can purchase less golf balls with that. Yeah.
Oh, okay. Thank you.
Yep. Mm-hmm. Right. Okay. And so that's an example just to kind of illustrate to you what the different rates are and how they mean. Okay. And then now let's talk about a little bit more terminology. So I've kind of already been using this terminology a little bit in that example, but it's going to be useful just to write it down. Okay? And so this is the types of money that are used for inflation calculation. Okay. Okay. All right, so the first one that we'll go over is actual dollars. Okay. And so actual dollars, you know, the way I kind of think about this is that this is money that you can actually touch, okay? Or the money that you actually use to exchange for goods, okay? Okay. Okay. And so sometimes actual dollars are called inflated dollars since inflation reduces their value over time. Okay. Okay. And so, you know, say that you have $100 bill, right? So that $100 bill is actual money that you can touch and you can actually pay for stuff, right? And so if you go back, you know, like 10 years and you save this $100 bill, you stuff it into your desk and say, you know, 10 years from now, I'm going to use this $100 bill to buy 100 fish tacos, you know, on a Taco Tuesday. And then you wake up from your cryostasis 10 years later and you realize that that $100 bill can only probably buy you like maybe 60 fish tacos. if you're lucky. And so, that actual money has gone down in value over time, even without considering interest rates, because inflation has increased the prices of fish tacos. Yep, today's Taco Tuesday. That's right. Now I want tacos. Okay. And so that's so that's actual dollars. Okay. And so the other type of money that we'll go over is real dollars, which I'll admit these are terrible names for these terms, just because real and actual are kind of almost synonyms, but they do have a very big difference here. Okay. And so real dollars, it's not actual money. So it's even though you have $100 bill, that's not actually real dollars. So what real dollars actually represent is this concept of purchasing power. Okay. And so, because inflation rates inflation always causes prices to increase, when you express real dollars, it always has to be based on some time period. Okay. And so, like, if you have $20 today, and you can buy $20 worth of stuff today, then you say that you have $20 worth of purchasing power in 2020. Okay. Okay. So these are often called inflation-free dollars because they've been adjusted for the effects of inflation. Okay. All right, so the key here is that that these real dollars, they have to be based in a certain time, okay? And so you can't say, I have a real amount of $20, because people are going to ask you, $20 worth of purchasing power when, right? Because $20 of purchasing power is different in 2020 as it was in like 2010, as it was different in the year 2000. Okay? And so when you're talking about real dollars, you're talking about purchasing power. It has to be within a certain time period so that people can kind of judge how much stuff that you can buy with that $20. Okay, and so there's going to be a relationship between these actual dollars and the real dollars and the three rates that we discussed previously. So the relationship between them can be kind of confusing. So on the next page, I'm going to basically write out some of the rules for you on what rates to apply to which dollars and when to use when. Okay. Before I do that, are there any questions on the differences between actual and real dollars? Okay. Okay, so let's go over the rules in between them. Okay. Okay. All right. And so the first rule concerns actual dollars in one time period and actual dollars in another time period. Okay. And so in this case, we're going to use our market rate. Right? So this was similar to our previous example, right? So our previous example, we had a market rate of 5.5%, right? And we used that 5.5% to say that the $1,000 that the golfer invested today is going to grow by 5.5%. And so in a year, she's going to withdraw $1,055 worth of actual money, okay? Money that she can touch, okay? Okay, and so by the same token, and so if we convert real dollars, real dollars of some with a certain time base, to real dollars with the same base but in another time period, okay? Okay, so in this case, we're going to use the real interest rate. Okay, so real goes with real. Okay. So an example of that could be like, say if you have, $1,000 worth of purchasing power in 2020, if you wait 10 years and then the real rate is say 5%, then, what you're going to express is that, in 10 years, you would have X amount of money worth of purchasing power if you were back in 2020. Okay. Real recognizes real, yeah. that's one good way to remember it. Okay. And so this is when things get tricky. So the first two rules are pretty straightforward, and so this is when things get a little bit tricky. Okay? And so in this case, let's say that we want to convert actual dollars in one time period to real dollars okay, of the same base as the actual dollars. Okay. And so what I mean by that is this is real dollars that's taken in that has the same purchasing power as the actual time where your actual dollars are taking place. Okay. Okay. At the same time period. Okay. And so remember, for real dollars, we have two things. So you have the time base, which represents its purchasing power, and then you have the actual time that you're actually evaluating. Okay. Right. And so if this is the conversion that you want to do, then you apply no interest rate. Okay. Because these actually represent the same thing. So I know this one's kind of a brain twister. So let me explain this a bit more. Okay. And so what this basically means is that, actual money that you have in some time frame also represents the amount of purchasing power that you have in that same time frame. Okay. And so if you have $20 today, that $20 is actual money that you can touch, but that also represents $20 worth of purchasing power that you have in 2020, right? And so if you compare, actual money at one time and the purchasing power at the same time, okay, then those are the same thing because they represent, you know, those things actually coincide, right? And so, you know, if you had, you know, let's say that you had $20 worth of, if you had a $20 bill back in, you know, 2010, okay, that $20 can get you $20 worth of stuff in 2010, okay? And so that $20 is actual money in 2010, but it also represents the real dollars in 2010 as well, okay? And so I know there's kind of a lot of things, and it's kind of a lot of, you know, language and brain twisters, but, you know, that's this is kind of a key concept. So, you know, I think you just say it to yourself kind of a few times and it starts to make a little bit more sense, okay? All right, any questions on this? Okay. Okay. And so that's 3. So that's kind of the tricky one. And so 4 is kind of the one, you know, that's actually used. Okay. This is when you would actually convert between real and actual at different times. Okay. And so rule 4 says that if you're converting real dollars, okay, and we'll say that these real dollars have some base t. Okay. Okay. And so their base is some time period t at some different time. Okay. And so we'll call this different time n. Okay. And so there's 2 time points here. So we have a time t, which is when our real dollars are based in, and then a time n, which is some different time. Okay. And then we want to convert this to actual dollars at time n. Okay. And so in this case, we're going to apply the inflation rate. For n minus t periods. Okay. All right. And so just a very quick example of this. So let's say that, you know, we have a real dollar amount at some base time in the past, right? And so let's say that we consider like $100 worth of purchasing power in 2010, okay? And then we want to convert this, you know, to a different time of actual dollars at the present time, okay? And so we want to see, you know, if we had $20 worth of or $100 worth of purchasing power in 2010, how much actual money would that be in time in today, okay? And so in that case, we apply the inflation rate in order to do that, okay? And so another way that you can think of this is that this is a conversion between real dollars at some base t okay, at time n to real dollars of base n at time n. Okay. Right. And so this other interpretation here, you know, it makes it seem like it's similar to rule 2, but remember the bases here are different. Okay. And so when you have different bases, and remember that represents different purchasing powers at different times, then you have to apply the inflation rate. Okay. Okay. So there's a lot of rules. So let me, I'm going to draw a figure that kind of summarizes this whole thing, which hopefully makes it a little bit easier to remember. Okay. But I think I'll do that on the next page because it's a little bit of a busy figure. And so before I do that, are there any questions on this? Okay. Okay, so let's draw a figure to kind of represent this. Okay, and so at the top here, I'm going to say that let's have a real amount of money, okay, at some time t. And so let me draw a timeline here. So let's say that this is time t, and this is time n right here. Okay, so this is time, right? And so this is a real amount of money base t at time t. Okay, and so this is purchasing power of base t evaluated at the same time. Okay, and on the bottom side here we have actual at t. Okay, and so this is actual amount of money at the same time frame. Okay, and so if we want to convert in between these two guys, you know, we apply no conversion factor at all, right? Because these are actually the same thing. And so the purchasing power at time t is the same as the actual money that you have at the same time, okay, with the same time base. Okay, and on the right here, let's say that we have a real amount of money base t, so purchasing power at some point in the past, but then we're going to evaluate that at some point in the future n. Okay, and so this was rule 2 that we went over before. Okay, and so in this case we use our real rate. Okay, because we're converting between two different real things with the same time base. Okay. And on the bottom, if we have the actual amount of money at time n, right? And so to convert between the actual at some time in the past and the actual at some time, you know, in the future, we're going to use our market rate. Okay. Okay. And so this thing we have in the bottom, that was rule 1 that we went through. Okay. Right. And then finally, in order to convert between these two guys, this was our rule 4. So this is for, so remember for rule 4, we apply our inflation rate. Okay? And so this F right here is inflation rate. Okay. And then we're going to apply F for n minus t periods. Okay. Right. And so if you want a kind of a visual representation of our 4 different rules, you know, this is kind of the thing that you can look at. Okay. Okay. And so, you know, I want to drill this into your guys' heads that when you are talking about real dollars, remember real dollars represent purchasing power, and purchasing power, you know, has to have some kind of time context to it. So you can't just say just blind purchasing power. You have to say purchasing power at some year, at some time. Okay. And so when you're talking about real dollars, you know, you have to remember, you know, what is the time that's associated with it. Okay. Okay. Are there any questions on this before we jump into one more example? Okay. All right. So I think we'll start this example and then we'll finish it up on Thursday. Okay. Okay. All right. So let's say that a sports stadium was constructed in 1965 with a cost of $1.2 million. Okay? Okay. And so after the construction was finished, let's say that the team owner wanted to invest another 1.2 million to pay for a future replacement. Okay. And let's say that that replacement is to be built in 2020. Okay. And so let's assume the following, okay? Right, so let's assume that we have an inflation rate of 6%. Okay. And let's assume that the $1.2 million that the owner invested is going to grow at a market rate of 8%. Okay. 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 And so let's do the following. So in part A, let's compute the real interest rate. Okay. And then let's also characterize the original $1.2 million purchase in terms of actual and real dollars. Okay.
Professor, does that say, or what does that say after change?
Compute where?
Compute real interest rate.
Oh, it's supposed to be characterized, so it's supposed to be one word. Sorry.
Oh, okay.
Yeah. Okay. All right. So on the last breaths of my my iPad, because it's being very uncooperative today, my iPad wants to evacuate right now too. Okay. So let's very quickly compute the real interest rate. Okay. Okay. And so real interest rate, since we're given the market rate and the inflation rate, we can compute it as I minus F all over 1 plus F. Okay. Okay. And so if we plug in the numbers, we have 8% for our I, and F is 6%. Then we have a real interest rate of 1.887%. Okay. So pretty straightforward there. Okay. Okay. And so the second part of this this part is to say that we want to characterize our initial $1.2 million purchase. Okay. In terms of real dollars and actual dollars. Okay. And so that 1.2 million, that was actual money that the team owner actually paid out to buy the stadium. So that 1.2 million is actual money that he spent in 1965. Okay. But what that 1.2 million also represents is that it also represents the purchasing power in 1965 as well. Okay. And so this kind of goes along with Rule 3 that we talked about before, that actual dollars that you spend in some time period also is the same thing as real dollars in that same time period. Okay. And so that 1.2 million, because he used that to buy the stadium, that's actually, that's a real $1.2 million worth of purchasing power in 1965 as well. Okay. All right. So you can characterize that 1.2 million as actual money that was spent in 1965, and that 1.2 million also represents real dollars in base 1965. Okay. All right. Any questions on that part? Okay. So that's all we got time for today because it's 2:15. And so we'll pick up this this example on Thursday and finish it out, right? And so, you know, so on Thursday, I think after Thursday, you know, we'll I'll put up the poll for the midterm review session too. Okay. So thank you everybody for tuning in today. Hope everyone stays safe. You know, try to stay inside if you can and evacuate if you need to. And I'll see you guys on Thursday. Thanks everybody. Thanks, you guys too.
Professor?
Yep.
I just had a question as to on part C, where we did the repeated inflation for 8%.
The part C of the example we did earlier?
Yeah.
Okay. Let me go back to it. This one?
Yes. But it would be, I think the next page.
Oh, next page. Okay.
Yeah, right there. Above. Why did we subtract by 1?
Right. So this is basically the same thing as if we did you know, $200 or 200 golf balls times F over P with a minus 2.23% for 1 year. And so basically, you know, the real interest rate basically, or in this case, it was, yeah, the real interest rate. This represents the fact that we're going to have 2.3% less purchasing power. And so the way I kind of quantified that was to say that if we could buy 200 golf balls today, if we had 2.3% less purchasing power in a year, how many golf balls would we be able to buy? And so that's why I did 1 minus 0.023, and then I multiplied that by 200. So it's just a way to kind of just represent, you know, we can buy less golf balls in the future if the inflation rate was much higher. Yeah.
Okay, and then that's what you did for 2%.
Yeah.
Oh, okay.
Yeah. And so for the 2%, you know, we kind of went about it in a different way. So for the 2% in part B, what we did was we computed the price of the golf balls, which is, you know, 510. And then we computed how much money she would have in the account, which was 1,055. And then I just took kind of the ratio in between. So with these prices and with that amount of money, we could buy 207. And then 207 divided by 200 is 1.035. And so another way that we could have done part C is that we can say that in 1 year, we would still have $1,055, okay? But if the price of golf balls went up by 8%, then the price of golf balls will be 5 times 1.08. So golf balls will be 540, okay? And so if we divide these two numbers, we take 1,055 divided by 5.4. Okay, we do that on the next page. So we do, there's not much room here. So let's see. I'll do it at the bottom of this page right here. And so we take, you know, 1,055, which is the amount of money that we'd have from the bank account. And then we divide it by $5.40, which is the price of the golf balls under 8% inflation. And then what we get is 195 golf balls. So that's another way that we can obtain the same thing. But for part C, I kind of just use the real interest rate just kind of directly to compute that. Yeah.
Okay, thank you so much.
Yep. Rawapi, did you have another question? Okay. So I'm going to end the call. So if you have any more questions, you know, I have office hours right after this. But if not, have a great day.